Hello everyone, my name is Tikhon Pachin. This is my submission for LAB2 for ECE 40862 in Fall 2021. Here is my code for taking the input of the date. This is the real-time clock to show, to instantiate the data or the date. This is printing the initial instantiation. I use timer number 1 to show the date every 30,000 milliseconds, which is the equivalent of 30 seconds. My handler is the date printer, which simply prints the real-time clock. I use analog to digital converter for my potentiometer. I also use a timer with 100 millisecond periods, and the callback is pot reader, which is the potentiometer reader. For LED, I use the pulse width modulation, and I would set up the LED frequency and LED duty cycle. And for the button, I simply use the regular GPIO general input-output pin. I use the state to show in which state currently is the system to update either the frequency or the duty cycle of the LED. And this is the handler for updating LED values in terms of frequency and duty cycle as well. So I used a trigger for debouncing, a button trigger for debouncing, and I used a third timer to update LED values so that the change in the frequency and the duty cycle would be a lot smoother than in instant change. Okay, so this is the code. So here is the hardware. As you can see, I've connected the 3.3 volt pin to my distribution strip around the board. I use the ground as well to connect to the ground. And both my switch and the potentiometer take in the 3.3 volts and ground, and they output the value that is desired by the switch or the potentiometer. And then they both, and all of them get connected to, I believe it was IO32 and IO33. Yes, the reason why I use the IO33 for the potentiometer, which is right here, is because it is associated with analog to digital converter 1, not 2. This is specifically channel 5, but it didn't really matter to me which channel I used. And this pin could be used as a general pin, input, output. For LED, I connected it to pin 27, IO27, which is 6th pin, I believe, and it can be associated with pulse width modulation, and the output of the LED is the ground on my board. So I'm gonna demonstrate how this works. I'm gonna quickly soft reboot, and I'm going to import the library. Okay, so it's asking for the year. Today's 2021. Month is 9/27. Let's say Monday's the first day. Hour. I'm doing it in the evening. Minute 34. Second right now is going to be 45, which is fairly close. And let's not worry about the microsecond. So as you can see, it prints out the current date, the one that I input. The microsecond will be iterated because some time has passed since I inputted the values between the print statement and the input of the values, and in about 30 seconds we will see the change, but I'm going to for now show the LED. And the LED is flashing at exactly 10 Hertz frequency and 256 duty cycle. And if we update the potentiometer, nothing is going to change. Nothing changes. Okay, so now if we use the first interrupt, if we press the button, we should see the change in frequency. It's a smooth change because I use the timer for the change, and the maximum frequency that I selected was 10 Hertz, and the bottom frequency would be 0. Oh, sorry, 1. Okay. So it's a smooth transition. And if I press the button again, it should change the duty cycle. So the LED becomes either darker or brighter. So this works. And the transition is pretty smooth. Okay, and just to show you that the data is iterating, we can see that this is 15 seconds, this is 45 seconds, this is a minute later, 15 seconds, 45 seconds, and 1 minute later. The microseconds are hard to control, so they will be iterating by a little bit each time, regardless of the code, because it takes some time to print the statement. And I have also used debouncers. This is not a debouncer, but this is a noise reduction for the duty cycle, for the potentiometer values. It doesn't matter much for frequency, because the frequency, if we convert the 4095 into 10, so the scale is from 0 to 4095 to 0 to 10, the change, if the potentiometer is fluctuating in the readings, it's not going to affect it at all. Now, if we take a look at 256, instead of 10, it's going to fluctuate a little bit, so I implemented the value of 10 as the maximum fluctuation that we disregard in either direction. And yeah, this is it. Thank you for watching.